the idea is we have a right angle triangle here with sides A, B and C. So you guys already know that if I have three sides A, B and C in a right angle triangle, it will be A square plus B square is equal to
C square.
Right? Can you guys think of any quantity that would represent A squared?
5.
Huh?
5. 9.
5, 9. No, but I am talking about a geometrical significance. For example, I can draw a line of length A. I can make that A is equal to anything. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 12.2. Can you think of anything that would represent A squared? A square of length A, its area will be a square having side length, a square having side length A. What will be the area of that square?
A.
So that is A square. Similarly, a square whose side length is B.
B square.
Similarly, a square whose side length is C.
C square.
So that this is exactly what Pythagoras theorem states, that area of this square plus area of this square is equal to area of this square, right? So essentially, if I can make these two squares fit in this particular figure, that would mean that this area, the sum of areas of these squares is equal to the area of C square, correct? So now we will cut it in a certain way so that the area of R squares, so this one is already fitting here, correct?
Yes,
but I cannot make this fit because now you see there is an overlap, right? So how can I make it fit? So I'll cut it in a certain way so that the areas of these squares will add up to the area of the larger square, right? So the idea is I'll cut them in such a way that these two squares will overlap this larger square perfectly. Okay. What I have done here is I have cut the smaller square here, this square, into strips, right? And I have given you, deconstructed this square into smaller parts to give this as the sum of the squares. Now what your task is, over the next 3-4 days, think about how I can cut this in a better way to fit this square perfectly. Okay. So that's your task. So think about it, take your time. So when we meet again on Thursday, I'll show you a better way to cut this or deconstruct this square into smaller pieces so that it will overlap it even in a better way and it won't be as long as this one. Okay. Sorry?
Put the bigger triangle, then we can take this and cut this much out and then place it.
Yeah.
So you're saying that take this much out, take this much out, or take this much out?
You can do
like as well as like this is.
no, like you can do this way as well. We can put it like this and this one you can cut.
Yeah.
The problem is I'll have to cut it out from one square. This has to fit exactly here plus here. So again you will have to break it down.
Yeah.
Right? So try and
You
think
can do
of
it
it.
better in a triangle so that it can fit.
Exactly. So try and see how you can break it down into triangles instead of fitting it into rectangles.
Diagonally, then
But how? If you just break it down diagonally, this will fit here. If you break it down diagonally here, it will fit here on this side. Right? Again, you will be left with two triangles that have to fit between this irregular shape.
I got the triangle idea. I will see how I can fit that.
Right? So think about it. Don't think about the diagonal though. Okay, that will not.
Triangle, but different.
Not diagonal.